हाय एवरीवन, होप यू ऑल आर डूइंग वेल। सो क्वेश्चन क्या है आज का। मेरा एक बहुत ही खास स्टूडेंट ने मुझे क्वेश्चन भेजा था। ये पाथफाइंडर का क्वेश्चन है। तो क्वेश्चन है कि यहाँ पे रिंग दिया हुआ है जिस पे चार्ज का डिस्ट्रीब्यूशन है। मान लेते हैं वो पॉजिटिव चार्ज है। अगर ये पॉजिटिव चार्ज का डिस्ट्रीब्यूशन है इस रिंग पे, तो तुमको क्या करना है, तुमको फाइंड आउट करना है ओ पोजीशन पे, ये वाला जो पोजीशन है ओ पोजीशन, इस ओ पोजीशन पे पोटेंशियल। तो पहला क्वेश्चन ये है। दूसरा वाला क्वेश्चन क्या है कि लेट्स एज्यूम देयर इज वन अदर पॉइंट आल्सो एट हियर, मींस इस सेंटर पे नहीं पर सेंटर के आसपास ही कोई एक पॉइंट होगा, उस पॉइंट पे भी तुमको पोटेंशियल फाइंड आउट करना है। तो जो पॉइंट मान ले कि r डिस्टेंस पे है वो, और वो सेंटर से कितने दूरी पे है, कितने दूरी पे, यानी स्मॉलर, मतलब कि स्मॉलर दूरी पे जो कैपिटल आर से छोटा होगा, मतलब यहाँ हो सकता है, यहाँ हो सकता है, यहाँ हो सकता है, कहीं भी। तो इस दो पॉइंट का तुमको पोटेंशियल फाइंड आउट करना है। पहला वाला पॉइंट है वो पॉइंट और दूसरा वाला पॉइंट है ये वाला पॉइंट। तो कैसे करोगे पोटेंशियल फाइंड आउट? यू नो द फॉर्मूला ऑफ पोटेंशियल, V इज इक्वल टू के क्यू बाई आर। एकदम बेसिक से फॉर्मूला है। अब छोटे वाले कोई पोर्शन के लिए मैं ले लेता हूँ dv, q के जगह में मैं ले लूंगा dq। तो v इज इक्वल टू के इंटू डी क्यू बाई आर। अब dq कैसे निकाले? dq इज इक्वल टू मैं लिख सकता हूँ लैम्डा इंटू dl फॉर ए लीनियर चार्ज डेंसिटी। आप लोग को दिख रहा होगा dq इज इक्वल टू लैम्डा इंटू dl। अब देखो लैम्डा तो मेरे को दिया हुआ है, मैं सीधा सीधा पुट करूंगा लैम्डा नॉट साइन थीटा। ऐसा क्यों कर रहा हूँ? क्योंकि यहाँ पे चार्ज का जो वेरिएशन है वो वेरिएशन कांस्टेंट नहीं है, इसलिए मेरे को करना पड़ रहा है। ठीक है, actually the charge variation is not constant over here, so that's why you need to do like integration dq. In place of dq you have to put lambda dl, and in place of lambda you need to put lambda sin theta. And for dl what you can do, for dl you can draw another line and this is d theta. So if this is d theta, this can be termed as r d theta. Why? Because this one is r. As you know, if this one is d theta and this one is r, so you can write this one is r d theta. Okay, so in place of dl you can write r d theta. Done. So now k will be written as k, this is r, you can write as r because this is the distance from this smaller charge portion to this point. And in place of dq you can write lambda naught sin theta r d theta. Done. So r and d cancel out. Now you can write k lambda naught sin theta d theta. So for this one, if you need to find out the potential, you just need to integrate both sides. So just doing integration and putting the limit from 0 to pi, 0 to pi. So as the theta is varying from 0 to pi, so 0 to pi, so that is coming like k lambda naught sin theta. You can put the limit 0 to pi. So for integration of sin theta d theta, you can write it what? Cos theta, actually minus cos theta. And whenever you put pi and 0, the value coming like 2k lambda naught. This is the potential at this point O. So this was the first question that we found out. Okay, I think the lower portion is not visible to you, so this one is the first question. Now moving on to the second question. The second question was like this. You need to find out the potential at a point which is not on the center but some distance away from this center, that is r away from this center. So we just will move into the next page. So what you can say, again I need to draw the figure and need to draw the point also. Let's assume this is a point, this is O, and I am assuming the point is at here. I am just enlarging this one so you can get a broader perspective. And let's assume for this portion you have to find out the potential. So you just draw this one and again this one. Okay. So this is the first concept. So now in this time you need to find out the potential at this position. Okay. So again in the same manner you can write it theta. This strip, for this strip you can write it d theta. Okay. So if this is r, this one you can write as r sin theta, and this total you can write r cos theta. Okay. So as you have to find out the potential in this point, what you can write at this point, you have to find out this distance. This you can term as x. So to find out the distance, you may write this one square plus this square is equal to this square. So this is how much. Or you can say if this is r cos theta, you can write this as r cos theta minus r. So this one square plus this one square is equal to this square. So that is r cos theta minus r square plus r sin theta square should be equal to x square. So that means x you can write as like this way. So for further deduction you may write r square cos square theta, r square sin square theta you may write as r square plus this one you may write r square minus 2r into r cos theta. This one is your x. Now what you need to do, again the same formula, potential V should be equal to k q by, now this one is x. So for x you have to put this one, and for q you just need to put dq and do an integration. So k will be remain as it is, and dq you can write lambda into r into d theta. Okay. So for dq you can write that is lambda into dl. In place of lambda you may write lambda naught sin theta, which was given earlier, lambda naught sin theta, and dq is lambda dl. In place of dl what you can write, I am just writing r d theta. Done. And this is as x, what you can write, just put this one at here. Now make an integration. So for this further deduction you can take this one as x. As I was saying earlier, this total values may be taken as x. R square plus r square, better minus 2r into r cos theta you may take as x square. Now you have to you have to make differentiation with respect to theta. Okay. So what you are getting, this one is out, this one is out, 2r you may write as it is, minus differentiation of cos theta is minus sin theta d theta, and at here you can write 2x dx. So 2 getting cancel out, minus minus out, x dx is equal to r. I am just minimizing this one, r into r sin theta d theta. So this r into r sin theta d theta, this total thing r sin theta d theta, this is here only. You just put here, substitute this as k lambda naught x dx. Take this r in the denominator of here, by r, and again for this one you may write this is as x. Now this one is cancelled out. Okay. Okay. Now what you need to do, k lambda naught h dx by r. So just put integration and limit of dx would be what? This place is r minus r and this one is r plus r. So r minus r to r plus r, that is k lambda naught by r. Whenever you are putting the limit r plus r minus r, and you are getting the same thing, that is 2k lambda naught. Okay, so the potential at this point and at any point on the diameter of this half ring will be same. So you can write both the potential as same. So that is Vp to any other point, that is Vq, should be equal to 1:1. So that's all for you. We will be posting more few questions from Pathfinder and all the Jee advanced problem, whatever we can feel that those are important. So I will be posting those things. Okay, keep liking. Thank you.